All right. So the rule that we're going to talk about today is called power to a power. And we use this property when we have an exponent being raised to another exponent. And so what we have here is 5 squared that's being cubed. So it's literally 5 squared times 5 squared times 5 squared. And then from yesterday, we know that that should be 2 plus 2 plus 2 gives us 6. So what do you think we do with these two numbers? We multiply them. Because a 2 times a 3 gives us a 6. Here's another example. If I have x squared to the 4th power, that's x squared times x squared times x squared times x squared, which is x to the 8th, because that's 2 plus 2 plus 2 plus 2. So I don't want us to do this anymore. What I want us to do is see that this is an exponent raised to a power. So 2 times 4 gives us 8. All right. So here's the rule. Oh, I guess it's not. Let's write this down. I got ahead of myself. These are 2 more examples. I hope those in the back can see it. It's a little small. I apologize about that. This is what we're about to do, kind of like the distributive property for exponents. And it is where common mistakes happen. So on the first one, we're going to distribute the squared to both numbers. So it would be a negative 6 squared times a 5 squared. And you might be saying, Ms. Sorensen, you're a liar, because yesterday you told us we can't do that. But that was with addition. If I have x plus y squared, that is not x squared plus y squared. That is not true. It's a lie. The only time you can do this distributive property with exponents is when you have multiplication. Okay, this next one here would be a 5 cubed. See how I have to do it with everything? So that's going to be equal to a 5 cubed. And then the 3 hits the x, and that would be an x cubed. And then that would be a y cubed. Now this last one here, okay, that's going to give us a 4 cubed. Now here's the tricky part here. We're not just saying, oh, it's just the x cubed, y cubed. Here we actually have to do some work. What would be the x squared cubed? Remember the rule we just learned? What does this become? X to the 6. Good, because we're doing 2 times 3. Okay, then on the outside of my parentheses I have times x to the 5th. Well, now we go back to yesterday what we learned, and we're going to do what with these two numbers? Add them. So we have 4 cubed times x to the 11th. Now, I didn't do this because it wasn't important at the time, but we actually can simplify this one. 5 cubed is 5 times 5 times 5. It's 125. And I'm not sure I know this one by heart. 4 times 4 times 4 is 64? It is? Yeah, it is. So this one will be a 64 x to the 11. Sweet. All right, Now let's write down the rules, because we've actually just discovered 2 rules. So what I have on the board here are all 3 of the rules we've learned so far. You do not have to write down the top one. That's what we learned yesterday. That when we multiply exponents, we add a and b. But here we did just learn that if we're raising a to the power of b here, we'd multiply it. And this is a reminder that we do distributed property. So it takes some time to get that down. I will never ask you to memorize this. I don't care the names of them. What I care is that you know this. Ready? Almost. All right, I'm gonna push the next button, don't panic. These are the 2 things that you're missing from the last slide, probably. This right here, that's the power rule. And this is the power rule as well. All right, so let's do some practice. We'll call this example 1. Let's do 4x cubed y squared cubed. Let's try that. Well, first of all, we've got 4 to what? 4 to the third power. Then it becomes x to the 9th. And then, that's a 9, looks like an x. And then y to the 6. 2 times 3 or 3 times 2 is 6. And that's it. Okay. Let's make it so that we have to use all 3 of those rules in example 2. So we've got, let's do a 2y cubed x to the 4th squared times x cubed. Notice how I basically have something beyond the parentheses. So I know some of you started it, but we've got 2 squared, which you can just write as 4, because 2 times 2 is 4. This becomes y to the what?
6.
Yep. And then x to the
8.
Yep, because I'm doing 3 times 2 gave me the 6, and then 2 times the 4 gives me x to the 8. Okay, then I just rewrite this, and this becomes essentially like yesterday's homework. So all I did was copy this down again. And now I say to myself, I've got a 6 and a 4, so that's going to be y to the 10th. So don't forget my 4, but I've got 4y to the 10th. And then I've got x to what power?
11.
Exactly. stuff. I'd like to do one negative exponent, and then I'll let you start your homework. We're going to go over both homeworks 1 and 2 tomorrow, just because we did the quiz corrections today and we're short on time. But let's do a negative exponent one. And I don't want you to feel like it's any different than what we've been doing. It just, I know sometimes negatives can be scary. It's kind of like your mom when she's angry. So let's do something like n to the negative 4 times n to the 4 times x to the negative 3. So I'm just going to rewrite the n to the negative 4 because it's kind of outside the parentheses. But this becomes m to the what power? Yeah, you're not fooled. It's just 4 times minus 3. Good, and then I've got a 1 here. It's not there, but I can write it as a 1. So this becomes x to the negative 3. And it does not look like I can combine any of those. All right, so nothing huge there. If you do end up, and you don't have to write this down, with something like x to the negative 5 and x to the 2, you're doing the same thing where you're just doing negative 5 plus 2, and that's giving you negative 3. All right, you might be able to get a big chunk of this done. Go to worksheet number 2.